Good morning, students. In last lecture, we have discussed about the boiler efficiency and boiler example of boiler efficiency. See here, in this lecture, we have to discuss case study of the boiler. So, what about case study? See here, installing a boiler economizer, a paper mill. We have to consider a case study of paper mill economizer to the existing boiler. The general specification of boiler is given. See here, this is a boiler capacity. Boiler capacity is 8 ton per hour. Feed water temperature in degree Celsius is equals to 110 degree Celsius. Steam pressure in bar is equals to 18, and fuel oil, that is furnace oil. The thermal efficiency of the boiler was measured and calculated by indirect method using the flue gas analyzer and data logger. The result is summarized like this. Thermal efficiency is equals to 81%. This is already case study done in the book. Flue gases temperature 315 degree Celsius, CO2 percentage is equals to 30, CO ppm is equals to 167, right? So by this the temperature in the flue gas is in the range of 315 to 320 degrees Celsius, right? So the water heat in the flue gas is recovered by installing an economizer, which transfer waste heat from the flue gases to the boiler feed water. This result in rise in feed water temperature by the about 26 degrees Celsius. So basic data is average quantity of steam generated is 5 ton per hour. Average flue gas temperature is 315 degrees Celsius. Average steam generation is 14 kg. Feed water inlet temperature is 110 degrees Celsius. Fuel oil supply rate 314 kg per hour. Flue gas quantity. This is the case study in a paper mill. We have to do such type of practical in any one paper mill or household device, household systems. We have to do this case study. So cost economics is given in this book also. Then conclusion, the recovery of waste heat by installation of economizer, the paper mill was able to save 13 kg per hour of furnace oil, which amounts to about 1,11,800 kg of furnace oil per annum. The economizer conserve the energy or conserve the fuel. See here, next point is energy conservation in steam distribution system. See here, steam has been a popular mode of conveying energy since the Industrial Revolution. Steam is used for generating power and also used in process industries such as sugar, paper, fertilizers, chemical, food, synthetic, etc. Some characteristics of steam make it so popular and useful to the industry. First characteristics, highest specific heat and latent heat. Then highest heat transfer coefficient, easy to control and distribute, and cheap and inert. These are the good advantages or good in nature of high specific heat, etc. So next, steam distribution. Steam distribution system is essential link between the steam generator and the steam user. So whatever the source of efficient steam distribution system is essential if steam of the right quality and pressure is to be supplied in the right quantity, so to the steam using equipment. So installation and maintenance of the system are important issue and must be considered in the design stage. So we have to draw the diagram about the steam distribution. I'll draw the diagram, very simple diagram. See here, see here, steam. This is steam, feed pump, feed stock or feed tank. These are the pressure valves, pressure vessels. These are the pressure vessel. This is pressure valve. This is condenser. This is pan. This is steam. Space heating systems. So this is condensate. So this is all about the steam distribution system. As the steam condenses in the process, flow is induced in the supply pipe. Condensate has a very small volume compared to the steam, and this causes pressure drop, right? So which cause the steam to flow through the pipes due to the pressure drop. The steam generated in the boiler must be conveyed through pipe work to point where its heat energy is required. Initially there will be one or more main pipes or steam mains which carry steam from the boiler in the general direction of the steam using plant. So Smaller branch pipes can then carry steam to individual pieces of equipment. So a typical steam distribution system is this. So the working pressure. The distribution pressure of steam is influenced by a number of factors but is limited by the maximum safe working pressure of the boiler, the minimum pressure required at the plant. As the steam passes through the distribution pipework, it will lose pressure due to frictional resistance with the pipe within the pipework, condensation within the pipework as heat transfer to the environment. Therefore, allowance should be made for this pressure loss when deciding upon initial distribution pressure. Next point is energy saving opportunities. See here, first is monitoring steam traps. In a boiler there is a steam traps. For testing steam trap, there should be an isolating valve provided in the downstream of the trap, and a test valve shall provided in the trap discharge. So steam trap monitoring is important in the energy saving. So next, continuous steam flow and no flow indicates there is no problem in the steam trap. Next, avoiding steam leakages. This is very harmful to the energy conservation in the boiler. Steam leakages. Steam leakages is visible indicator of waste and must be avoided. Has been estimated than 3 mm diameter hole on a pipeline carrying 7 kg per centimeter square steam would waste 33 calorie of fuel oil per year. Next, providing dry steam for process. It is very important to provide the dry steam. Wet steam does not provide high much power, so the best steam for industrial process heating is a dry saturated steam. Wet steam reduces total heat in the steam. Also, water forms a wet film on heat transfer and overload traps and condensate required. So superheated steam is very important to conserve the energy. Utilizing steam at lowest acceptable pressure for process. And 6.1 is proper utilization of directly injected steam. 7th is minimizing heat transfer barriers. 8, condensate recovery. And 9th, insulation of steam pipelines and hot process equipments. So insulation, there are 9 points. You have to write only 5 to 4 points when question will ask like energy saving opportunities. 9 point is installation of steam pipelines and hot process equipments. heat can be lost due to radiation from steam pipes. So it is common to see living flanges uncovered. Next, energy conservation opportunities in compressed air. This is very important. Energy saving opportunities in compressed air systems. So compressed air system, air compressor account for significant amount of electricity used in the our country. Air compressor are used in a variety of industry to supply process requirement, to operate pneumatic tools and equipment, and to meet instrumentation needs. Only 10 to 30% of energy reaches to point end use, and balance 70 to 90% energy of power of prime mover being converted to unusable heat energy, and to lesser extent lost in form of friction, misuse, noise. So the leakage problem, actuation problem, blow conveying, tools here, these wastage are in a compressor. So suppose I will draw Sankey diagram for this. This is percentage of output. So waste heat waste, this is leakage, this is actuation, this is conveying, as per percentage blow, and this is tools, that is air, hose, air, etc. So efficient operation of compressed air system, first one is important, location. So location of compressor, it is very location of air compressor and the quality of air drawn by the compressor will have significant influence on the amount of energy consumed. Second, cool air intake, this is also very important, as thumb rule, every 4 degrees Celsius rise in inlet air temperature results in the higher energy consumed by 1% to achieve equivalent output. Next, dust free air. Dust in a suction air causes excessive wear of moving parts and result in malfunctioning of the walls due to abrasion. Suitable air filters should be provided. Fourth one is dry air intake. The atmospheric air always contains some amount of water vapor depending upon the relative humidity. Being high in weather, the moisture level will be high if air is drawn from the damp area. So next, fifth is elevation. The altitude of the place has a direct impact on the volumetric efficiency of the atmosphere. The effect of altitude on volumetric efficiency is given. Avoiding for this, avoiding air leakage and energy waste, these points have to consider in the compressed air. Next lecture we will discuss energy conservation opportunities in a refrigeration and air conditioning. So thank you very much.